Morning and welcome back to class. Today we're going to click on the assignments button. Remember, all assignments, including the reading assignments, are located by clicking the assignments button in Blackboard. We are going to click on week 1 assignments, and we are going to briefly look at the measurement and error reading assignment. So click on read, measurement, and error. From here, we are going to click on accuracy versus precision. Most students do not struggle too much with random errors and systematic errors, so we'll just skip right forward to accuracy versus precision. From here, make sure you read each of these little reading assignments, which are located in these little windows. These are called prezzies. Again, if it says required reading, you need to make sure to read it. We're going to continue. What we're going to look at is, we're going to look at a set of data. We're just going to keep clicking forward until we find our data set. Here it is right here. So here is our set of data. And what we're going to do is we are actually going to take the thermometer readings from thermometer number 1, and we are going to calculate the percent error of the calculations made by thermometer number 1. Now, what is percent error, right? Let's click to continue and just look. Here is our formula for percent error. It is equal to the average of the measured values, so we'll take all of the measured values for thermometer 1, we'll average them, minus the accepted value of whatever it is we're measuring, divided by the accepted value times 100%. The percent error, what it does is it tells us how closely the average of a set of measurements agrees with the accepted value of whatever is being measured. Percent error is a good way of determining the accuracy of a set of measurements. So what we're going to do is we're going to go back to our data table. And again, what we'll be doing is calculating the percent error for thermometer number 1. Now, if you remember, the percent error formula asks us to not only find the average of the measured values, but asks us to find the actual or accepted value of whatever we're measuring. So we need to figure out what that is. What's the accepted value of whatever we are measuring? And if you notice, at the very top of the page it tells us. The table below shows a set of measurements made by 4 different thermometers. The thermometers each took 4 measurements of the temperature of a beaker of boiling water. Thus, we know the accepted value for the temperature of boiling water is 100 degrees Celsius. So in our percent error formula, for the accepted value, we will be plugging in 100 degrees Celsius. So I have actually set up a little Word document with some work in it. So here's our data table. Here are the 1, 2, 3, 4 measurements made of the temperature of boiling water made by thermometer 1. Again, we know the formula for percent error is this. The average of the measured value minus the accepted value divided by the accepted value. To find the average of the measured value. So we need to find this, the average of the measured value. To do that, we take all of the 4 readings for thermometer 1, we add them together, so 99.9 degrees Celsius plus 100.1 degrees Celsius plus 100 degrees Celsius plus 99.9 degrees Celsius, and we divide by the total number of readings made by thermometer 1, which is 4. So we take 99.9 degrees Celsius, 100.1 degrees Celsius, 100 degrees Celsius plus 99 degrees Celsius divided by 4. So let's just do that. So 99.9 plus 100.1 plus 100 plus 99.9 equals, and then we divide the whole thing by the total number of measurements made by thermometer 1, which is 4. And we're left with 99.975 degrees Celsius. This we will take and plug in for the average of the measured value in our percent error equation. Again, we know the accepted value for our boiling water. It is 100 degrees Celsius. So 99.975 degrees Celsius, we plug in for the average measured value in the percent error equation. 100 degrees Celsius, we plug in for the accepted value or actual value in our percent error formula. So when we plug in 99.975 degrees Celsius for the average measured value and 100 degrees Celsius for the accepted value in both of these places, 100 degrees Celsius here and 100 degrees Celsius down here, we have 99.975 degrees Celsius minus 100 degrees Celsius equals divided by 100 degrees Celsius times 100. Oh, where'd you go? Times 100. And what we're left with is negative 0.025% error. So our percent error is this. Negative 0.025%. Make sure you ask if you have any questions at all.